Hello my dear students and welcome once again to Zenith Academy Online. We are on the chapter sound and in this module we'll be talking about reflection of sound waves. So in particular we'll be talking everything about echo. So this video is for class 10. Let's start and study the reflection of sound waves and the phenomena known as echo. So first we'll talk about reflection of sound waves. So when a sound wave traveling in a medium strikes the surface separating any two media. So suppose this is a medium, okay, this is maybe air or this is water, okay, two mediums are there. So when a sound wave is incident like this, when a sound wave traveling in a medium strikes the surface separating any two media such as wall, metal sheet, hardwood, etc. So what happens? A part of the incident waves get reflected into the initial medium. Okay, so a part of the incident wave get reflected into the initial medium obeying the laws of reflection. So when this is incident like this, it will get reflected obeying all the laws of reflection. What are the laws? That the angle of incidence, this angle is equal to angle of reflection, and all the incident wave, the reflected wave and the normal, this is the normal, they all lie in the same plane. But the rest of the wave gets partially absorbed and partially refracted on the transmitted into the second medium. So some part of the wave is reflected back, but some parts gets refracted. So if this is the incident wave, okay, instead of passing straight, it has moved like this, it has bent like this. So this is the refracted wave, right? Have you understood? So there are two phenomena have taken place. Here there is reflection that is taken place, and here if you see, this is the incident ray, okay, instead of passing straight, it moves towards the normal because this is a denser medium, this is air and this is water, for example. So it has moved inside and this angle has decreased. So if this was theta 1, this is theta 2. Remember that theta 2 will be less than theta 1 if this medium is denser. Okay, I have already explained you all of this when I was teaching you refraction, right? So reflection of sound waves follows two things, reflection and refraction, correct? So initially, see, when a sound wave traveling in a medium strikes this surface separating the two media such as wall, sheet, hardwood, a part of the incident wave gets reflected into the initial medium. So when it comes like this, let me change the color. So when this is the incident ray, it will reflect back in the same medium obeying all the laws, but some of it will get bent and get transmitted into the second medium. Okay, so we can say it is absorbed or refracted or transmitted into the second medium. This is how reflection of sound wave takes place. Now you must have done this experiment in your lab. If you have not done, please understand it here. Okay, so this is what I have taught you just now. This is the incident ray when it reaches the surface. This is the surface separating the two medium. Some of it gets reflected like this and some of it gets bent, and this is the refracted wave. So it follows all the Snell's rule and everything. So here is the experiment which shows this. Okay, so I am explaining you the reflection. Okay, here. So here we keep a wooden board, okay, something like an obstacle or a wall. Okay, and we take two cardboard tubes. Okay, one cardboard tube is here, another cardboard tube is here. I will take the pointer. So this is one cardboard tube, this is another cardboard tube. Okay, now I will keep a stopwatch here so that there is a tick sound. You know what is the sound of stopwatch? It keeps on making some sound, tick 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 tick, correct? So I'll keep it at a particular angle. Also in this in the schools, it has the apparatus already has, see, if this, like your compass, your protractor, okay, this is 0 degree, okay, 10, 20, 30. So all the markings are done like this. Okay, all the markings are already made. So what do I do? For example, I take 30 degree here. Okay, I keep it fixed at 30 degree, this cardboard. Then I move this other cardboard. Okay, I keep on moving this cardboard. So I start from here and I keep the cardboard moving like this. And I keep my ears, okay, around the end of the cardboard tube. And I keep on moving. So at a particular point, I will hear very distinct and very loud sound of the stopwatch. There I have to stop. Okay, I hope you have understood this. So what I have done, this I have kept at a fixed place, say for example 30 degree. And I start this cardboard from here, I keep on moving and I stop at a place where I hear a very distinct and loud sound, and I will note this down. So when I will note this down, I will see this is also 30. So we verified that the angle of incidence is equal to angle of reflection in the case of sound waves also. So not only light, the sound wave also obeys the laws of reflection. So the laws are exactly like light wave. Now what is the condition that is necessary for the reflection of sound wave? Okay, so in the case of light, okay, you remember in the case of light, if this is the surface, this is the incident ray. If I draw this as normal, okay, this will reflect back like this. So what was the condition? This surface has to be a very polished surface. It has to be a polished or very smooth surface. That was the requirement. Correct? Now, in the case of reflection of sound, there are two conditions. For reflection of longitudinal sound waves, so in the previous class I have explained you what is longitudinal, and most of the time I told you in air the sound wave is longitudinal, so we will be talking about longitudinal. So for reflection of longitudinal sound waves, the first condition is size of the reflective surface should be bigger than the wavelength of the sound wave. This is most important. This size of the reflective surface should be bigger than the wavelength. So if he is speaking, this is the full wave form. Okay, so this some wavelength is traveling like this. So this size has to be bigger than the wavelength of the sound wave. This is the very important and most important part, most important condition necessary for reflection. So if the wave, if the size of the obstacle, okay, from which the sound touches and bounces back, this size, okay, of the reflective surface should be bigger than the wavelength of the wave itself. If this size is smaller, the sound will not get reflected. So when just now I am sitting here and I keep a book in front of me and I talk, okay, a small book in front of me, so I will see that sound is not getting reflected back, right? Because the wavelength of my voice is bigger. So for the sound to reflect back, the size of the obstacle has to be bigger, right? Let's go ahead. Now, unlike light waves, sound waves do not require a highly polished or shining surface for reflection. This is very important. लाइट वेव के जैसे साउंड वेव्स को नहीं जरूरत है किसी भी हाईली पॉलिश्ड या शाइनिंग सरफेस की reflection from any smooth or rough surface happens provided that the dimension of surface is large enough. So the sound wave can get reflected, sound waves can get reflected through rough surface also or smooth surface also, both through rough or smooth. Okay, whereas if you remember, light gets reflected only through smooth surface. If the surface is rough, for light, if the surface is rough, okay, you know what type of reflection happens here? The diffused type of things happens, है ना? Diffused reflection, if you remember. Proper reflection does not take place. Let's move ahead. Now, sound audible to us. Audible means that we can hear. So sound audible to us have a very wide frequency. You know what is the frequency of audible sound? 20 Hertz to 20,000 Hertz. This is the audible sound. 20 Hertz to 20,000 Hertz. Okay, and thus, so since the range is so high of frequency, it is so wide, okay, thus a wide range of wavelength is formed. As a result, the overall nature of refraction varies according to the texture and the structure of surface on which the sound waves of a particular frequency is incident. So you have to remember, if I am talking about this wall, I told you if I am speaking here, if there is a speaker here, okay, then this wavelength, this size should be more than the wavelength. I told you this. So since this frequency range is so high of audible, so the wavelength range will be also high. Okay, so the quality of sound that is reflected, or the overall nature of the reflection, will change, will vary according to the different surface, will vary according to the texture and structure of surface on which the sound wave of a particular frequency is incident. Correct? So different type of frequency sound goes and strike on different surfaces, so the overall nature of reflection will vary according to the structure and the texture of the surface of a particular frequency. Now let's come on the most important part of reflection of sound, that is echo. Okay, so we have often experienced that if a person is standing on a hilltop or any empty room which is surrounded by big walls, and if he shouts loudly, two sounds are heard, right? One is the sharp original sound of the person heard instantly. So when I am talking, I am able to hear my own sound, right, instantly. The moment I am speaking, I am able to hear the sound without any time lag, isn't it? While the other is the faint sound heard after some times. So suppose this shepherd is shouting. Do you know about this story? This is the story of the shepherd and the lion. Do you remember? So go ahead and watch these stories if you don't remember. So if he is shouting and if there are mountain cliffs, okay, the sound will go here, strike and come back to him. Okay, so first instantly he will hear his own sound, then the sound will go back, reflect and come back to him. So that will be second sound, which is a faint sound which is heard after some time. And this sound is heard after reflection from hills or walls, and this is called an echo. So let me explain you echo in detail. What is the definition of echo? How do you define echo? The sound heard after reflection from a distant object, दूर वाला object, distant मतलब दूर वाला object. It is very important to mention the word distant, okay, like high building, a cliff or a mountain, etc. After the original sound from a given source dies off. In some books they are written ceases मतलब मर जाता है या बंद हो जाता है, is called an echo. So what is echo? Echo is the sound heard, the second sound which is heard after reflection from a far off object. When are you able to hear it? After the original sound from the given source dies off, okay, or ceases. So what is the condition for formation of echo? Right now when I am teaching you, I am not able to hear the faint sound. So why is my sound not getting reflected from the walls, and why am I not able to hear the echo? So there are two conditions for the formation of an echo. First is minimum time and minimum distance. There has to be some minimum time and some minimum distance. So what are they? Let's talk about minimum time. Okay. It has been found out that the sensation of any sound persists for 0.1 second in our ears after the original sound from the source dies off, and this time is called persistence of audibility. So इसका क्या मतलब है? The sensation of any sound persist मतलब remains, है ना? So if I have spoken something, the sensation of that words, okay, remain in my ears for how much time? For 0.1 second. Okay, after what I have spoken has gone off. So it remains there for 0.1 second. So when I am hearing something, okay, it remains here for 0.1 second. But if I immediately hear other sound, okay, if there are so many sounds coming, I am hearing a sound and the second sound comes before 0.1 second, then I am not able to hear that sound. Correct? So right now when I am speaking, okay, it's me, and when I am speaking, so I am hearing my original sound, and if this is a wall around me, I'm hearing the other sound also after reflection, but the time gap between them is less than 0.1 second because the wall is very close to me. Okay, so even though I'm listening to the reflection of sound, but the time is less than 0.1 second, so I will be able to hear only the first sound because that is there in my ears still, right? This time is called persistence of audibility. So if any sound after reflection reaches our ear in less than 0.1 second, it cannot be distinguished from the original sound. So an echo cannot be heard. Thus, the condition for formation of an echo is that the reflected sound should reach at least 0.1 second after the original sound ceases. So when this person is speaking, okay, sound is traveling like this, hitting a mountain cliff or a far off wall, coming back, okay, and if it is taking time more than 0.1 second for the second wave to reach his ears, then he will be able to hear the sound. But the intensity of sound will be not that, because some energy is lost in traveling through the air. So that loud sound he will not hear. He will hear a faint sound. I hope this is very, very clear to you. Why the sound is faint and what is the minimum time? 0.1 second. So if you want to hear an echo, the reflected sound should come to your ears after 0.1 second of the original sound. Correct? Have you understood? And this, what is this 0.1? This is the persistence of audibility. Okay. Let's go ahead. Minimum distance. Now minimum distance required between the source of sound and the reflecting surface to hear an echo distinctly is 17 meter in air. So the distance between this person and this hill should be at least 17 meter. Okay. In many of the books you will see 17.2 meter. I will tell you why. So you listen to me very, very carefully now. Okay. See, we know that speed is what? Speed is equal to distance by time. Now, so this speed is, now see, if this is the distance, if this is the distance, so how much has the wave traveled? The wave has gone like this and it has come back. So it has traveled 2 times, first here and then it is coming back. So distance, if I take the distance between observer and the cliff as d, the sound has traveled twice. So it will be 2d and this will be time. So velocity is 2d by time. So I can say distance, देखो 2d will be v into t if I cross multiply like this. So only d will be v into t divided by 2, isn't it? Now what is the velocity? So the distance will be how much? What is the velocity of sound in air? It is taken as 340. Okay. And minimum time is 0.1 second. If I divide it by 2, I will get 17. Okay, have you understood? Now somewhere in some books it is around 17.2 or 17.19 etc. because they take the exact value of sound in air. Sometimes the value is taken as 344 or 343 etc. We have taken here the standard as 340, so it will be 17 meter. The exact value is 17.21 something, right? So if you take all the decimal values properly, then it will be 17.2 exact. Okay, not exact, it is in decimals. I hope you have understood this. So I will read this thing once more. So minimum distance required between the source of sound and the reflecting surface to hear an echo distinctly is 17 meter in air. If the distance between the source of sound and the reflecting surface is less than 17 meter, okay, usually in our houses the walls are close to each other, so distance is always less than 17 meter, then the echo will not be heard because the reflected sound wave will reach the ears of the observer simultaneously with the original sound. Correct? So for minimum I have taken 0.1 second because minimum time is 0.1 second. I hope you have understood how we arrived at 17 meter. Okay, let's go ahead. If you have any doubts, you can write in the comment box below and I will be happy to help you. So now we studied what are the two conditions for formation of an echo. We studied two conditions for formation of an echo. Now we will study about conditions for hearing an echo distinctly. If I'm able, what are the conditions required to hear that echo which has been produced distinctly or properly? So first is the minimum distance between the source of sound and the reflecting surface should be 17 meter in air. Then the wavelength of the sound should be less than the size of the reflecting body, then only the reflection will take place. I have already explained you this. And the third and very important thing is the intensity of sound should be sufficient so as to hear the reflected sound. So you have to scream very loudly so that after reflection also when the sound comes back, okay, the intensity is so much that you are able to hear it. Okay, so intensity of sound should be sufficient to hear the reflected sound. Otherwise, sometimes the sound is so faint that you are not able to hear it even though the reflection has taken place, right? So the intensity, the number of waves of sound per unit area has to be more. Very interesting condition known as reverberation. Okay, reverberation is nothing but repeated echo. Okay, we can say repeated echo is also known as reverberation. Okay, so when a series of repeated reflections or repeated echo, so reverberation is repeated reflections, fall on the ear from various reflectors one after the another, the sound gets prolonged and a continuous rolling sound can be heard. This is known as reverberation. You must have seen in certain halls etc. when the speaker comes on the mic and say something. Okay, so you hear a very loud shrieking noise, prolonged noise, continuous rolling sound. Ting karke you hear something, right? Very loudly. So that is nothing but reverberation. So what is reverberation? If you see the diagram carefully, okay, this is the speaker. So once he is speaking, first of all, this is the direct sound, directly the listener will listen to him. This is the direct sound. Now, if the sound goes there, reflects here, again reflects here, two reflections, and then he is able to hear. Okay, then sound may travel like this, gets reflected and he is able to hear. The sound may go like this, reflect here, again come here, reflect here, and then fall into his ears. So there are so many reflections happening. So when the listener is listening to this sound, after when it is reaching his ears, one after another by getting reflected on different surfaces. Okay, so when the series of repeating reflections fall on the ear from various reflectors one after another, the sound gets prolonged and a continuous rolling sound can be heard. This is called reverberation. In simple language, you can say that reverberation is a series of repeated reflections of sound waves. Okay, I hope you have understood this. Now to reduce this reverberation in the cinema halls etc., what do? These reflectors, the walls or maybe the curtains and all are made up of such materials that they absorb sound, they do not reflect sound. So if these all surfaces 1, 2 and 3 surfaces are absorbing sound, then we are able to hear only this direct sound. We will not be able to hear all these certain reflections. So in the cinema halls, even the seats covers are made up of materials such that those materials are good absorbers of sound. If you see the walls of the theaters or of big halls, you will see that they are very rough, okay, made up of such materials that absorb sound. Okay, the curtains, we make curtains in a house so that the sound is absorbed and not getting reflected, right? All these are the reasons. Even on highways and all, they plant trees on both the sides or in between so as to absorb the noise created by the automobiles, and these are all noise absorbers. So for reverberation, this effect occurs only when the distance between the reflector and the source of sound is less than 17. Okay, if it is less than 17, then only reverberation takes place. If it is more than 17, then echo will form. So reverberation will be formed when there is no echo. When there is no echo, then only reverberation is formed. Example, reverberation occurs if person speaks in large empty room or enlarged monuments such as the Taj Mahal. Right? You must have seen in many monuments they tell you to scream. So from the top it comes back and you are able to hear. The distance is more than 17 meters there. Sorry, the distance is less than 17 meters there. Now, this is very important application of echo. Use of echo to determine the speed of sound in air. Okay. So, how do you determine the speed of sound in air? So, can you see this person? So, this person maybe, shoots a pistol or fire a cracker, okay, which is having a very loud sound. The sound travels, okay, hits the mountain cliff or a large wall, okay, and reflects back. So, when he is striking this, simultaneously a stopwatch is started. Okay, and then when the sound is heard back, the echo is heard back, the time is noted. So in this way we determine the time taken. We determine the time taken by the sound to reflect and come back. Isn't it? Have you understood? So the person stands at a known distance d. The person is standing at a known distance d. Suppose say 100 meter. Okay, example. Okay, from a cliff and fires a pistol or a powerful cracker to produce sound. Simultaneously, while firing, he starts a stopwatch. The stopwatch is stopped as soon as the echo is heard. Now, let the time interval noted be t. So, this is the time interval which is noted. The distance traveled by the sound during this time is twice the distance. So, if this is the distance between the source of sound and the cliff, okay, then the distance traveled by the sound will be 2d. Because the sound has moved like this, distance d, and from here to here the sound has moved and sound has come back on the same path. So twice of d, d plus d, twice d, this is the distance, right? So the speed of sound is how much? Speed ka what is the formula? Speed is equal to distance by time. Speed is distance by time. So the distance is 2d and the time is t. So this is how you can calculate speed. So we take multiple readings, है ना? So by repeating the experiment a few number of times, we find the average speed or the average velocity of sound in air, and that will be the speed of sound in air at that particular place. I hope this is clear to you. Now we are doing different applications of echo. The first and very important application is sonar. Sonar. Okay, the full form is sound, navigation and ranging. Sound, navigation and ranging. So here from the diagram itself it is very clear there are different transmitters and transducers. The transmitter sends the sound waves down. It reflects on the maybe the seabed or certain wreckages of ships or some large fishes, etc., and it bounces back. The transducer records it, notes the time taken, and hence we can calculate the distance. Okay, so see here, it is a technique of using ultrasound sound waves. Ultrasonic sound waves are used, not the audible sound. Okay, so ultrasonic sound waves has the frequency more than 20,000 hertz. So why do we use this? To locate the underwater objects. If there's a big iceberg, okay, or some broken ship, etc. So to locate the underwater objects. It is used by warships or the sailing ships to locate underwater submarines. Now warships should know if there is a submarine down, or even to find the depth of the ocean bed and so on. Okay. So as the ultrasonic waves, now why do they use ultrasonic waves? The reason is ultrasonic waves can travel undeviated. It travels undeviated. Okay, undeviated. It does not deviate much. Okay, it does not get bent much. So an ultrasonic wave can travel undeviated underwater for many kilometers and are not easily absorbed by the medium, not easily absorbed by water. unlike the sound in the audible range. The sound in the audible range can get absorbed by water, it also gets deviated. So that is why we use ultrasonic waves, because it can travel in underwater undeviated for many kilometers and do not get easily absorbed by the medium. And this method of finding out the depth of the ocean or to locate submarine or iceberg etc. is also known as echo depth sounding. Now in this, what is done, can you see here, there is a transmitter. This is the transmitter and this is the detector. So transmitter sends the ultrasonic waves down, it strikes the bed or it strikes any obstacle here and it comes back. So the time is noted, and by this formula distance is equal to Vt by 2. We have just now done this, because it is twice the distance, it has traveled twice distance. So distance is equal to velocity, velocity is distance by time. So distance is 2d in this case, right? So if you cross multiply, 2d is equal to Vt, therefore d will be Vt by 2. This is how you arrive at this formula, Vt by 2. So we know the velocity of sound in air, we know the velocity of sound in water, right? This is water inside, right? So we put the velocity of sound in water, we take the time that we have noted, we have noted the time here and we divide by 2 to find the distance, to find this distance. This is the distance d. I hope this is very clear to you guys. Now let's talk about radar. Now radar is radio detection and ranging. Radio detection and ranging. So here you can see in the picture there are so many these type of objects. Can you see this? Now what are they? Let me explain you. Now in this case sound waves are not used. In this type electromagnetic waves are used. Electromagnetic waves. Please remember here, in sonar which sound waves are used? Ultrasonic sound waves were used. In this technique, in radar, radio waves are used. Electromagnetic waves of long wavelength. The wavelength has to be long, such as the radio waves. So in radar, which waves are used? Radio waves are used. Many a time students make this mistake. Radio waves are used in radar, not sound waves. They are used to locate an enemy aircraft or ship. Radio waves are sent in all directions in space. So here you can see from this, the radio waves are sent in all the directions. This keeps on moving also. This portion keeps on moving and keeps on sending radio waves in all the directions in space. And during wars and all, it is used a lot for finding climatic conditions and all, also it is used, radar. So radio waves are sent in all the directions in space. The radio waves on striking an aircraft gets reflected, which are in turn received by the receiver on the radar device itself. So now when this is transmitting, these are the waveforms. Transmitting, it is striking the target, enemy aircraft, and the sound wave is reflected. This is the emitted wave and this is the reflected wave. On receiving the radio waves, the position of the enemy aircraft can be located. So in the same way we did, d is equal to Vt by 2. We know the velocity of radio waves in air. We have noted the time taken and hence we can determine d. So we do not do this calculation manually. There are computers done. Jaise we are receiving time, on the very instant it is giving you the location of the target. So you know that the enemy aircraft is approaching. Now next is use of echoes by fishermen or trawlers. So you can see there is this trawler. It is sending some sound waves down. And this is the shoal of fish, a full group of fishes. Then the sound will hit their body and will get reflected. This is the echo waveform. This is the waveform of the sound waves which is sent through transmitter. Again it is accepted and recorded transducer by transducer, and we know the distance between this. Accordingly we can use our instruments to catch these fishes. So this is how a real trawler looks like. So similar to sonar, a trawler sends a beam of ultrasonic waves. It is also sending which waves? Ultrasonic waves from a source into the sea. Okay. The waves on striking a shoal of fish reflect to the source and are received by the detector. The distance of the fish can be calculated by noting the time taken by the waves to reach back to the receiver. So with the same formula, d is vt by 2, we can find out the distance of the shoal of fish, and accordingly utna hi niche we put these nets down and we receive the fishes. I hope this is also clear. So here which sound waves are used? Ultrasonic sound waves are used. Okay. Here ultrasonic, here radio waves, here ultrasonic sound. I hope these three uses are clear. Now use of echoes by animals such as bats and dolphins. So see here, this is a bat. You know what are bats, right? Bats can produce and detect high frequency sound waves of about 100 kilohertz that does not lie in the human audible range. Okay. Now these waves, humans are able to hear only 20 to 20,000. Okay. And here this is 100 kilohertz, 20 to 20k hertz, and here it is 100 kilohertz, so much far, 100 kilohertz. So we are not able to hear the sound that is produced by bats, so that does not lie in the human audible range. These waves are used to locate the obstacles at night. These sound waves strike any obstacle in their path and reflected as echoes to the bat's ears. These echoes guide the bats to fly safely in air, avoiding collision with any obstacle. And this method is known as echolocation or sound ranging. Okay, this method is known as echolocation or sound ranging. So you know that bats cannot see at night. So how do it catch its prey? So the bats emits the high frequency sound waves of about 100 kilohertz. Okay, it strikes the prey and gets reflected back. So this blue colored is what he has sent, red color is what he has received. In his mind he calculates the time and the distance, and then he catches the prey immediately. Okay. Now see what happens in dolphins. Dolphins use both. Okay, they use both. They use high frequency and low frequency sound for echolocation. You know what is echolocation? I have just told you here. The use of echo to locate the prey is known as echolocation. Okay. Now dolphins use both high frequency and low frequency sound for echolocation. The low frequency sound travel the farthest distance. Okay, so what is the use of low frequency? Low frequency sound has high wavelength. Okay, frequency and wavelength are inversely proportional. Frequency is shown by this. Frequency and wavelength are inversely proportional. So if frequency is less, the wavelength is more, so it can travel very far off, and it is used by dolphin to detect any object. The dolphin then switches, now it has detected the object, then switches to the high frequency sound to obtain a more accurate picture of the object. Correct? Now it switches to high frequency once it is located. Then they also use echolocation system for communication with other dolphins as well, to locate their prey or to avoid predators. So to communicate with other dolphins, to locate their prey or to avoid the predators that are chasing them. Okay, for all these purposes, dolphins use both high frequency and low frequency sound. Now use of echoes in medical science. How is echo used in medical science? So the echo method of ultrasound wave is used by doctors to observe the images. Images of what? Images of soft tissues in human body. Which soft tissues? Like liver, gallbladder, stomach and uterus. So ultrasound waves are used by doctors to observe the images of the soft tissues of human body such as liver, gallbladder, stomach, uterus. Here in the picture you can see the doctor is examining this person and seeing his stomach here. Can you see? Okay. This process is known as ultrasonography. So here the ultrasonic waves reflect off from the soft tissues. So here can you see that the doctor is holding something. So this instrument is releasing some ultrasonic waves. Okay, the ultrasonic waves we are not able to hear, but the ultrasonic waves goes inside the body, gets reflected from the surface of the body tissues, and we are able to see the image. Okay, now this sound waves that is coming back. So this instrument has both the things. This instrument is used, इसमें transmitter भी है and detector भी है. So it is sending sound waves, it is also detecting the sound waves which is coming after reflection, and then there is a converter here in the computer, in the system. So what happens, the sound wave is converted into the image, into the electric waves, and then the image is formed. Okay, so if the stomach is like this, for example, the stomach shape is something like this, so this sound wave, different sound waves that are falling onto it, so this sound wave will travel more, this sound wave will travel less and come back immediately. This sound wave on striking this will take more time. So according to the time taken by different sound waves, an image is created. Okay, so ultrasonic waves reflect off from the soft tissues and a computer transforms the reflected waves into an image on a computer screen, and this picture which is obtained is known as sonogram. This image is known as sonogram. Okay, sonogram. I hope this is, and this technique is known as sonography or ultrasonography. Now the same process, the process of obtaining the image of heart. So when I am talking about heart, the name, only the name changes, and this procedure is known as echocardiography. Okay, echocardiography. Here also the doctor is sending sound waves, ultrasound waves inside the body. There are different patches. Can you see there are different patches that are attached here, okay, which act as the receiver, and we get the different pictures, the different images of our heart, and we are able to understand that if there is any abnormality in somewhere or some valve or some wall, etc. Now there is this very interesting use of sonography in pregnant women. Okay, so by this, okay, two things we can do. First is here, if you see the first image, okay, the doctor is able to see the fetus inside. Okay, so that she is able to see that if the fetus is doing well, growing well, there is no abnormalities, etc. Okay, so the same technique is used to see the fetus inside. Also to hear the heartbeat. Okay, so all the time sonography is not done, but every month or after every weeks, okay, in a pregnant woman, to hear the heartbeat, whether the child, whether the fetus, okay, heart is developing properly. So to hear the heartbeat, this is a transducer or a speaker and a microphone, and you put it here and you get different waves like this, in the form of pictures, also in the form of sound. Also they can convert it into the sound and make you hear. So this is very, very amazing technique which is used to see whether the fetus is developing properly or not. So for more questions from this topic, you can go ahead and see the questions which are there in this particular book, Oswal Gurukul, most likely ICSE question bank. Okay, now this I have shown you for physics, but you have for biology, you have for chemistry as well. Okay, now physics, the sound chapter comes under this book. So topic wise also there are different questions here. You can go ahead and look inside. I'll give you the description of this book inside. Here the diagrams and all are given so perfectly, the answers are explained so nicely. So for a thorough practice, you can go ahead and buy this book to ace your board examination and get amazing marks in your board examination. and keep on following Zenith Academy online. We are coming up with the different more parts of sound chapter. Next chapter that I will be doing is electric current, and then after electric current I am coming up with chemistry chapter, calorimetry. Right, so keep your learning always on Zenith Academy online. If you are liking our videos, we have full range of biology chapters. All the biology chapters are done, all the chemistry chapters are done, most of the chemistry chapters are done, and we have got amazing response for chemistry. And now we are doing physics as well. So we have English, complete Hindi, everything is there on our channel for ICSC, for CBSC, for state board. So go ahead and subscribe to the channel and please recommend it to your friends. Bye bye my dear students.